All right. We want to do vectors. So we'll look different things in this topic. We'll talk about polar Cartesian coordinates, vector themselves, scalars, resultant, angles, how to find angles, and also directions, and also just resolving something in two components. So without even wasting our time, let's get started, because we'll talk a lot of things that will even like cover the whole topic that you need, all the concept that you need in your university study first year. All right, so let's get started. So first thing that we are going to do is, let's ask ourselves to say what is a vector. So let's ask ourselves to say what is a vector. Okay, so there's this thing, a vector and a scalar. You learned in grade I don't know, it's grade 10, something like that. So a vector quantity and also a scalar quantity, they were two, and you even studied some examples, everything like that. So now that's what we are going to do as you come here in tertiary level, that's university. So we'll say a vector is anything. So a vector is anything, or you can say something. Okay, is anything that have both magnitude and a direction. Okay, then again let's ask ourselves to say what is a scalar quantity. So for a scalar, this one doesn't have a direction, it has only a magnitude. So it's just a magnitude, let's say 20 quart. So let's say the number just 10, that's just a magnitude. Okay, so we are interested in vectors. A vector is anything that have both magnitude and direction. So if it has these things, both of these things, magnitude and direction, so I can give you the measurement to say, if I tell you to say 20 meters, this is the magnitude. Okay, so if I mention of, let's say, east, then I'm talking about direction now. So meaning that this thing qualified to be a vector because it has a magnitude and also the direction. So I can say, let's say 10 meters north of east, meaning this is the direction now. So we'll be getting these directions from the Cartesian plane, because that's where we can measure, north. Our compass is the Cartesian plane. So let's say we have a Cartesian plane like this. Let's say we have a Cartesian plane like this. All right, so this is our Cartesian plane. So having this Cartesian plane, this is north pole, this is what first, this is south pole, right? You start with north, south. This is how we start. Okay, then you come west, then you come east if possible. So your interest should be north. North is what will be even telling us how to start, what's this, measuring angles, yeah, something like that. So I'll teach you one trick on how to measure angles. Let's get started. So we are saying this is our compass, so that's where we'll be. So this compass is, we can say, is a Cartesian plane. That's where we'll be getting all the directions of a certain vector. So a certain vector will be placed on this Cartesian plane so that we see. Okay, so if I put something like so if I put, let's say, north like that, so this is our what's this, our vector. So our vector, it has a direction like this. So say, let's say this is 15 kilometer. So since this is 15 kilometer, where, so you need to specify whether north of east or east of north. Okay, so if I say, so now let's get to know how to see where the direction should start from. So if I say north of west, okay, or if I say north of east, if I say I'm done with north. If I say south of west, and if I say south of east. So now what we do is of, that's where your starting point. Where are you coming from? I'm coming from Lusaka. So you say you are now CBU of Lusaka. So meaning you are from Lusaka. Of, that's where you start from. So this is our starting point. So if I say this was 20 kilometer, this 15 was 20 kilometer north of east. So of east then, meaning I start from of east, so of CBU of Lusaka. So meaning we're starting from here, of, that's where your starting point. So of, you measure like that. So that is it. So that angle that you have, that's how you get it. So that's how you get the angle. Yeah, that's about a vector and a direction. So we'll be placing it on a Cartesian plane. Okay, so we can also place it here. We can also place it here. So if you press it, let's say this is 20 kilometer. So this is our vector. So this vector, I can tell you to say it is the west of north, meaning you put your direction from here, of north. So I'll put like that. So that's the angle that I have, but the angle of interest, you see it. So the angle of interest should be here, of what I'll teach you. So that is it. So let me start with the scenarios, then you will see what is important from there. All right, so vectors, guys, are very simple, provided you know what is supposed to be known. So you can be studying a lot of things, but yeah, know the standard of your institution. So Bionza, whatever institution, but just know the standard and know the basics. Okay, so now that is a vector, and also how we can present it on a Cartesian plane. That's how we can present it. Okay, so a vector always will be having direction, a vector. So now let's say how are we going to be using this concept vector, or how are we going to be solving, or what type of questions are we going to be facing? Let's say I say alpha. Let's say alpha walks 4 kilometer north. So this is alpha. By the way, I'm not supposed to start like this. I start like this. Alpha walks 4 kilometer. Do this. Alpha walks 4 kilometer north, like that. North. Then he walks for, this is his starting point, by the way. So he walks 4 kilometer north. Then again 3 kilometer east. So I'll do this, I'll go to east like that. Okay, so that is my east. So now since I have my east like that, so I said he walks 4 kilometer north, then again walks 3 kilometer east, right? East like that. So we need to know about these two things. One, we need to see or what is his total distance. Is distance. Then the other thing is we need to know what is his direction. No, not really the direction. Let me say the displacement. Yeah, is displacement. All right, so that is the displacement. Then I can also ask you to say so this displacement I'm talking about is more like I'm asking you to find the resultant vector. Okay, so what will be the result vector after having those direction, because we were only interested with one vector, resulting vector. So that's what we call a resultant now. Okay, so let's get started. So as seeing this thing, so we are saying to find the total distance, you add, the distance, you are only interested in what you have covered. We don't want the shortcut thing to say we want the right path, no, as compared to my displacement. Anyway, before I even list that far, so the distance you add, so okay, so distance, you say 4 kilometer plus 3 kilometer, then what will be your result? So when you add this, they'll give you what? 7 kilometer, like that. So now finding the displacement, this is where now it will be an issue. So find the displacement, we need to know that this is the displacement for displacement. So this person started from here and ended here. So for displacement, we are not interested in what he covered. We are only interested for a straight path, because you displace something straight. Okay, so you displace something straight. So this is what we are interested in now. This is our displacement or resultant. How do we find this now? So we'll say we'll learn about Pythagoras theorem. So this can be something like right angled. Then if we are talking about Pythagoras, then let's name this as R. Okay, resultant. So I'll say R. So these are just adjacents. So we'll say R squared is equal to adjacent over plus opposite squared. So we'll say 4 kilometer. Oh, let me just forget about meter, because they will not there will be a variable, because that's the same unit we have been repeating. So I don't think there's that effect. Oh, let me just include them. So this is what 4 kilometer plus 3 kilometer, like that. So this is how we'll be finding the resultant. So this is our resultant, R. So if R is our resultant, then we are saying, remember these in Pythagoras, they are squared like that. They are squared. They are all squared like that. Or let me just do this like that. So now this is R. We're only interested with R, not R squared. This is R squared. So we'll do this. We'll say R, which is the resultant or the displacement. So you introduce the root, because you have cancelled this one. So you introduce the root like that. So then this will be Let me just square from there because there will be no need for me to do. So this will be what? 16 kilometer plus what? Plus this is 9 kilometer, right? So this is 9 kilometer, 16 kilometer. So when you do that, they are all squared, by the way. So once we load them, then we are having the half. So let's add the first. That will give us 25 kilometer. So 25 kilometer, what is the root of 25 kilometer? So this is the displacement or the resultant. So what is the root? The root will give you what? 5 kilometer. So this will be 5 kilometer. And you are done. That's how we find the resultant. Okay? That's how we find the resultant of a vector. So the other thing that we can talk of after finding the resultant, we'll be told to find the angle. Okay? So the angle, anyway, we'll come later to that, but the angle will be found by using tan in this case because we have adjacent opposite. Let's say we have the angle here. The angle, because the angle which is made is from this point. So say this is our angle. So if this is our angle, how do we find the same angle? So you say angle, this one. So it is now opposite over adjacent. You know, we learned about SOHCAHTOA. SOHCAHTOA. In SOHCAHTOA there is ta, like that, right? Where we have opposite over so this is not supposed to be hypotenuse because we have what we call the what's this, the TOA now, TOA, like that. So we have opposite, then adjacent. So adjacent is this one, opposite the angle is that one. So what you do is, so it will be tan is equal to the opposite now over the adjacent. So what is this opposite? The opposite of the angle where the angle is pointing at that, that's the opposite. So that's 3 kilometer, right? Or let me just say 3, then over 4, like that, then tan theta. So to find this theta, you say theta, you divide by tan. So it will be tan now. Once tan comes here, it will be an inverse over that thing. So this is 3 over 4, and you'll be able to find the angle. So of which now I don't have a calculator. Let's just punch. Let's punch. I have a calculator, I think. Okay, so that's how you find that's how you find the angle now. So we are talking about a lot of things now. So we are saying inverse tan 3 over 4. So that's 36 point something. So this is 36 point what? 0.87, like that, degrees. So this is the angle between these two vectors. So that is it. Yeah, you can find we have talked about the distance itself, the displacement. So the displacement is also called the resultant. So, and also angle. So on a vector like this, so we have talked about those things. So let's go. So those are the situations that you'll be facing, and it's important that you apply this knowledge because it will help you in your first year, test 1, session, or everything like that. It will help you. Just pay attention to this video. It covers everything. So that's the case. So that one you can even round up to whatever number whatever number you are told. So the other thing that we can talk of is what is polar and what is polar and Cartesian coordinates. So we want to know what a Cartesian and also a polar coordinate is. So by the way, when you are finding the resultant, so all right, so now we need to know how to resolve something into coordinates, I mean component. Let's say the vector is here, so allow me to present a Cartesian plane again. A Cartesian plane is given as follow. All right, so a Cartesian plane is given like this. So what we do is, let's say this is a vector, this is a vector, let's say 10 meters. So our north there, don't forget our east there, our west there, then our south there. So this is now a Cartesian plane showing north, east, west, south, something like that. So if we have this, so if I tell you to say, let's say I have different vectors, so always the angle that's most I'll give you is the angle from x-axis. So this is x-axis, this is x-axis. So having this x-axis, let's draw another x-axis. All right, so this is our x-axis. So once you see, this is where we used to see x coordinates, this is where we used to see y coordinate, meaning things that goes up therefore y, things that goes down, I mean horizontal therefore x. So this y will be going by with sine, right? Then this x will be going with the cos. Are you getting me there? Master this. So we'll be using sines for up things and for vertical, then cos for horizontal things, right? So that is it. So let me teach you now how to, so know that for cos we'll be going with the x, for y sine will be going with the y. So y things that are found up or down, something like that. So by each vector, so if I give you this, let's say this is a Cartesian plane again, so I align a vector like that. This vector can be of north, I mean of y, and it also can be of x like that. So this is x, this is y. So there is that debate which is taking place. So it can be of this side or of this side. That's why we are finding the resultant. When we find the resultant, this is the resultant, by the way. If we find this resultant, we are talking about something which will result after these things are pulling the, like they are debating on having this vector. So that's the resultant. So that's the resultant we are talking about. All right. So if that is the resultant we are talking about, then if this vector is 10 meters, then I give you to say 35 degrees. So how do we find the resultant of this one? So you'll be told to find the resultant given the angle like that. So the resultant now will be found like this. So you say R is equal to, so you have resultant of x and also of y that side. So we said that's for y, then this is for x. So for us to find the resultant, we can't just find the resultant if we have multiple vectors. So what we do is we find the resultant of each vector. So in the y and x, we find those resultant. So for this one, we are saying to find the resultant now will be saying R Okay, we'll be saying the resultant of this one. We have seen how we can calculate using the, what's this, we'll be saying uh cos component or sine component or x component, okay, plus y component. So they are component. So a component is a situation whereby I say let's say this is point A or vector A. So a y component of x component of vector A will be using that magnitude you have. So we're saying A is equal to that magnitude you have, which is 10. Then you put now cos, because you're talking about the component. So this thing I've talked about here. So you say cos that angle given. So the angle given is now 35, like that, degrees. So that's what will be going in the x toward x. That's the pulling thing. So that's what we call a component. So get it clear here. This is now x component because we have used the cos. So you say 10, you punch this, then you'll be able to get a value. Let's say, let me punch it. So that is 10 cos 35, 10 cos 35. So that's I don't know, 8. So that is 8.2. So you leave like that. So that is our what? Our resultant in terms of what? Why, in short, it's called now x component because you have tried it using cos, and that's x component. Okay, so yeah, that is it. So you'll be finding a lot of things. Especially, let me give you this. You'll be finding a lot of things, I mean a lot of vectors. So for the same A, so this was the x component. Let me write like a x here. This is now y component. For y component now, you say, so these were component, by the way. So this is our formula for components. Right? So if we are saying that is now that vector now y component, so we are saying now you bring the same 10, then now you put sine the same angle 35, like that. So you'll be able to find the answer. So let's try to find the answer. So we are saying, let me punch, is 10 sine 35, like that. So that is 5.2. So these are the component, y component and x of this vector. So let's say again we have this vector now. So what I can advise you now, let's get it clear now. I have a trick for you. So when you see a vector, let's say this is now B, now it is having 100 meters. So since this is vector B, then it has, let's say, the degree of 20, like that. So the degree is 20, the direction. So what we do is, instead of you having this thing, like, we can start from the 0 to measure this angle, because we'll be moving like this. So we'll be moving like this. So we'll start from here and also move like that. That's how we'll be moving. Now I don't want you to do this case. Instead, when you find a vector, so get it from from x-axis. So if it is like this, get it from here. So master this again. So if you have a Cartesian plane like that, you need to know that this side things are positive, up, then this side x is negative, this side x is positive, right? This side y is negative, this side y is positive, right? Then this side up, y is positive, this side up, I mean down, x is the negative because it is this side, it is this side. Then x this side is positive. Again y this side is up, again y this side is up, like that. So x is 2, y is negative, y is negative. So let's get it like that. So master things like this. So if it is like this, then you say we'll be just getting from here, and you know that is now negative. So it is now us to charge these things. We'll be charging the value, whether positive or negative, depending where we found it. So like for this case, for b, so vector b, so for vector b, this is vector b. So for vector b component, so we are saying x component, we are bringing that magnitude, which is 100. Then for, since it's x component, so now we are saying cos 20, like that. Okay, I won't put anything. I know this vector is charged a negative because I found it on a negative side, so I'm saying like that, 100 cos 20, like that. Yeah, because you know that that vector should be a negative because you have found the cos this side. So this is what I want you to get clear. So you punch like that, it will give you a negative value. Then you getting this angle, which is the total angle is 180, and 180 minus 20, which is here, that will give you 160. I don't want that situation of you calculating, measuring the angle. You end up making a mistake. So you should do this. You get this angle. So if it is like this again, I give you this, or I give you this angle here. Let's say it's 60. You know this is 90. So this one, which is here, it's just 40. So you'll be using 40 because you are interested in the angle that is coming from the x-axis. Then now start judging it. So for bx component, you have the answer with a negative view, so you punch the answer, you waste our time. Then for b again, y component, you say 100. So if we are saying now y component, have you seen now it's up, this vector is up of this thing, so it is going up of y. So we are saying it's now positive, so it's positive recharge. So it's 10, we start from here, so it's 10 sine, by the way it's 100, the magnitude was 100, then 20, like that. So now we are saying 100 sine 20, like that degrees. Then you'll be able to find, so that value should give you a positive because you saw that it is up. Y in this case is up. So if it is for this, let's say this is now the one you're interested from the x-axis, that measurement from the x-axis. So let's say this is 200 meters. So we'll be saying for this is c, vector c. So if it is vector c like this, we'll be doing what? We'll be saying for c x component, we are saying now x component, have you seen x cos is negative this side, then cos is positive this side. Hi, so now since cos is positive this side and is negative this side, so we say we'll charge this one is the negative, then you pretend to say we only have 40. Then you measuring from here to there, from here to there. No, I don't want you this. So you say that's 200 now. 200 cos what? 40, like that. So you put the value and you also include the negative. Let's say it's 8.0. I'm just assuming like that. So this is your component of x component. So for the same c, we can also find the y component. So we are saying this is now the point D now. So point D has, let's say, 300 meters. Then it is given now with the from, so 300 meters from south, meaning this is our starting point and we start from here and measure to there. So let's say this is now 37 degrees. So 37, we know that the total of this should give you 1 90. So 90 minus 37, 90 minus 37, that's the value that we are going to put here, and that's we are interested in finding in using this from x-axis. So we are interested in this, so just see and get the answer. So we are saying you punch 90 minus 37, which will give you 53. So this is the 53 we'll be using. So we are saying now for points d x component, we are saying you bring the same magnitude, which is 100 300 by the way, 300. Then you say, since this is for x, we are saying cos. Now cos, this side cos is positive, so we are just say cos 53. So having cos 53 degrees like this, so now we are charging it. Is it on the positive side? Yes, this side x is positive, this side x is negative, this side x is positive. So we are saying we'll write negative like that, then punch the answer. 300 cos 53 like that. So you find the answer. Your answer, no, this is not positive, it's positive by the way. You positive, it's found on a positive side, so you do this. This is positive. So manje, now you get you multiply this using your calculator. Let's say you find out, my calculator is giving me a problem, so let's say you're finding 27 like that. So you don't put any direction, just leave like that. It's just a value. You say resultant of that vector, so it's just a value, a magnitude, I mean, a value. So this is how you'll be finding. Then for y, for y it is also the same case. For y, you say dy is equal to, so now again y, now it's now down. So okay, we are saying it's now, you bring that magnitude, which is 300 sine. By the way, we use sine for y, right? That's what we agreed. So 300 sine 53. So now this thing that now down here, y is negative, so say d component y is equal to negative open bracket 300 sine 53 degrees like that. So then from there you punch, let's say you have, after punching this, let's say you have 21 like that, 0.2. So it's now negative because it's found down of y axis, so up like that. So this is how you'll be doing, treating, very simple. So that's how you'll be solving them. So let's have an example. Let's have an example. Let's have an example. Let's have an example now. So forget about this. Then after having those, that I forgot one thing. After having all those things you had, then you say for resultant now, the final resultant now that you have is now will be found by saying all the total resultant, all the total. So you add all the x's, you add like that, my x's, then you put total x's, okay, total of x's. So you say total x plus again total of y, like that. So all those components that you are from finding of each vector, let's say for 300 you had x and y, so you bring them here, then you load them. After adding them inside, then you load them. That will be a resultant. So that's how we find the resultant. Or you can do this. This is the total. You go and get the total, and also you get the total of y, and bring them here and add like that. So you say x, then you square like that inside, by the way, then plus y inside. So these are component. After you add the total there, the total of this and this, the total of x and the total of y, then you bring those component in this. Then you say resultant is equal to whatever you square root there. Then your resultant should give you the final even the measurement. Let's say they were in meters, let's say you find 6 meters as the final thing after you do everything. So that's how you'll be doing it. So that's how you'll be treating it. All right. Okay. Okay, so guys, these are things just that are involved, and it's important that don't get tired. I know it's boring, something that you haven't learned in class, but you can just start. And once you start, you see that, oh, this is what he was talking about, and these are the things that are not supposed to be left out. You even understand that. Okay, so we'll be given multiple vectors, and if you are given multiple vectors, that's what you do to treat those vectors. Okay, all right. So for example, let me give an example, but before I even give an example, let's do this. So we said to find now the x component, where say x component is equal to the resultant of that vector, then cos theta, right? Then to find the y component, we are saying that resultant that we are given, let's say is c on the Cartesian plane like that, then let's say this is 100. That's our R now in that case. Don't get confused. That's what I'm talking about. If I say resultant, that resultant is just the resultant of that vector. So I mean the given magnitude of that vector, that's this R you are able to see. Then for y, we are saying now sin theta like that. Okay, so that is the thing. So now that R is the magnitude you have, okay, and the theta sometimes will be given. All right, so if I give you the question to say, so a polar coordinate now will have x, a polar coordinate now will contain the angle, that angle you're able to see, this angle and this R, that's a polar coordinate. Then a Cartesian plane will have these now, x and y. So those are Cartesian plane. So if I say, let's say I give an example to say, okay, so let's say we have the example to say the polar coordinates which is x and y are given by the formula. Let's say I just give you the formula, or I give you the data. I give you the data. Let me just give you the data to say I have been given the polar coordinate, which are theta, okay, and the resultant. So those are polar. So now if I'm saying that, I'll say the theta now is given by like as 240 degrees. Then the R is given as 5.5 meters. 5.5 meters. So find the what? The Cartesian coordinates. So the Cartesian coordinates, now we are saying these are x and ri. So it's just a matter of coming and do this. So we are saying for x now as Cartesian coordinate, the Cartesian coordinate are x and y, which are these, right? So now we are saying for x now, I'll come represent like that. So for x now, you do this. You say you use r cos theta, right? Yeah, r cos theta like that. So since this is r cos theta, So this is ala cos theta. So we are saying now to find the Cartesian coordinate. So it's more like you are finding the component now, x component, and we are saying ala is what? 5.5. Then cos theta is 240. Okay, like that. So that's 240. So when you punch like that, you'll be able to get negative let me punch negative 2.75 meters. Okay, then for y component, you are saying you punch the same thing, ala sin theta. So this is y, by the way, y component. Then we are saying our ala now is 5.5, then sin 240, like that. So since this is sin 240, we are saying what would be that? When we punch that, it will give us negative 4.76. So negative 4.76. It's obvious that the vector was down of everything. So you say meters. So these are Cartesian plane. Then therefore the Cartesian plane will be, for x is this one, for y is this one. So these are Cartesian, you know, on a Cartesian plane. So that's how you find those alright, that's how you find polar and the Cartesian. So the other way around, let's say I ask you to say find the polar coordinate now, given these two. So given y component and x component, find the polar coordinate. So we say the polar coordinate will have theta and that ala. We know the formula to say to find x component is equal to ala cos theta, like that, right? So now we have x component. So we'll put, for x we'll put negative 2 point, right? So negative 2 point. No, before I even find that, so before I even find that, I need to find this ala. So if I find this ala, then let me do this. Okay, let me do this. So I have ala, I'm looking for ala, then there's cos theta, like that. So what I'll do is I will divide throughout by cos theta. So this is negative what? I said it's negative 2.7. Allow me to write just 2.7 like that. Or let me just say write 2.8 like that. So I will divide by cos theta, like that. So if then I'll have my ala is equal to negative 2.7 over cos theta, like that, right? So that is it. So now we know that in this one, for y, I'll say y is equal to ala sin theta, like that. So I have this, and what I'll do is I'll say what is my y value. My y value is now my y value, I know my y value, but what I'll do is I'll come here, okay, so that I find the theta. So I'll come here and do this and say y is equals to ala. I know ala is that, so I'll say it's now negative 2.7, like that, 5 for x, where then over cos theta. Then there's this sin theta here, sin theta. So this and this, they are giving you tan. So it's y is equal to 2.75 tan, right? Tan theta. So now you know this value for x, for that's negative 4 point something. So you're saying you're just dividing in short, 2.75. Allow me to lab here. Alright, so that's 2.75. This is now, this y is 4.76. 6. Then we are dividing, this is 0, so we are remaining with tan, then divide everything throughout. We are dividing 2.75, so 2.75. So therefore we are saying tan theta is equal to 4.76 over 2.75. So now to find the theta, now we know how do we do it. We say theta is equals to tan inverse of 4 point, if I'm not mistaken, that's 4.76 over 2.76. By the way, they were all negative, so they're giving positive, like you can see. So now that is the theta. I don't have a calculator. Yeah, so you'll find the theta like that. So that's one of your what, let's say you find, you for sure you will find the same thing, the same 240, so it will be 240. So after finding 240 degrees, so what we do is you say this is 240 degrees. After finding this 240, you say, okay, now that's my r. What about my r? You can use one of the x. Let's say I use y, so I'll say I'll put the value of y there, okay, and also after putting the value of y, then I'm looking for this r here. So you know the theta, you divide the sine theta of this, divide by this, then you find your r. So that's how you find the r, and for sure your r will be 5.5, something like that. That's your r. So it's the other way around just. So you are now okay with the polar and the Cartesian coordinate, right? You are now okay with that. Alright, that's good. So don't get tired. After this, then you solve a tutorial sheet. It will be of help. It will be of very much help. So let's say we have multiple vectors now. Now I give a scenario to say alpha was given to lead a map on how to find a certain mineral. So in his leading alpha, let's say he walks 200 meters due east, right? Then after walking this, he walks again 150 meters, then 45 degrees north of east, like that. Okay, let me say west. So let me say west, so that we trace the question. So of west. Then question now, find his one direction. Right? Find his direction. So after finding the direction, just we can also find the resultant and the resultant. Right? So we'll be finding the resultant and the direction. Let's see how we are going to find the direction and also the resultant. By the way, direction in this case is the angle. So let's get started. So we are saying now we can now analyze on a Cartesian plane. So this is a Cartesian plane. So this is a Cartesian plane. So having this Cartesian plane, we are told to say this guy due east. So if I say due east, it's just direct east. If I say due north, due south, you just go direct. Like this case is due east. So meaning the vector was along this. Wait. So this vector was along this x-axis. So we are saying this is our north, this is our east, this is our west, this is our south, right? So due, it's saying this guy walked due east. So east we are saying is now 200 in this horizontal thing, which is giving you 0 degree. It's giving you 0, so meters like that. So then again he walks 150, 45 north of west. So you say of, that's where you start from. So we can assume it's just between the north and south and west, right? So what we do is of, you start from west, so I'll measure from here and so of, you start from here and measure like that. Then you put your 45 degrees like that inside. Okay, so that's the vector at second he produced. So meaning that this is now 150 like that meters. Okay, so now how do we find the direction, the magnitude, or the angle? The direction is just the angle, direction 25 degrees, that's your direction of west, something like that. That's the angle. We're interested in the angle and the magnitude. So direction. Now let's start with the magnitude so that we find the direction, or we can just find with the, we can start with the is a direction. So what we do is you do the same thing. Sometimes you can use a table, you find the way of using a table, but me advise for x to say we are finding now for x, there are only two vectors. So for x component we are saying for this vector, it is what, if we were to measure like that, we measure angle like that from the x. So since it's just due, meaning it's 0 here, it's just within the 0 point, so it's not raised to some height, so it's 0. So we are saying we get the magnitude, which is 200, then cos, by the way it is on the positive side, so this is positive, then cos, the angle is now 0 because it's just due. So if I say due north, that's now 90, due west, that's 180, due south, that is 270. Due is just within that given south pole. So this is now 0 degrees. That's 0. Then plus I'm adding everything for x of all the vector given. So for this one now, I'll say that's now 150. By the way, it is now, x is now negative this side for this of this vector. Let's say this is vector A, this is vector B. So for vector B, x now is what? Negative, because the negative side of x, then positive side of x. So that's, we remember cos, everything like that. So what we do is we are saying negative, open bracket, negative 200, no, that's another vector just. So we are saying, let's see, 150 of this vector x component, 150 cos 45. Remember, this 45 is from the x-axis, so I said you should measure from x-axis just where you are given, and also from the x, and put the charge than you getting from the that point. So we get like that. So when you do this, so to say x component to give you, when you punch like this, when you punch there, this one will give you 200, because cos 0 is 1, so it will give you 200 like that, positive 200, then minus, this is minus by the way, so then say open brackets, so minus 150 cos 45. So we are punching 150 cos 45, so that will give us negative 106. So say, in short, it will give us 106 if you don't include, if you put 150 cos 45, so it will give us 106.1 like that. So this is a negative, so you say 200, let me just say 200. What is 200 minus c? 106 point something, 0.1. That's what we want to do. It will give you what? It will give you 93.93. So 93.93. That's your x component fine. Then for y component now, we say that's now, is it for this vector, is y on the opposite or what? We don't know, right? We don't know whether it's positive or negative, but for this case put positive because that's the starting point. We'll see what will happen. So leave everything because you don't know there. It's a 0, so a 0 degree, it doesn't, that's where the starting point, you don't have any charge. So you're saying now you put 200 sine 0, right, to find of this vector. Let's say this is vector A, this vector A. So we're saying 0 degrees. Okay, so then plus you add over there, you come for this vector. Now this vector is now from the x. We are interested with this angle like I give you. Don't measure from this to the it is also the other way, but it will waste your time, so I don't want things that waste time in. That's what I'm advising you. So you get this 45, so you say 150 now sine 45 like that. So sine 45 like that, then you say okay, when you punch like that, this one give you 0. You know, sine 0 is 0, right? Sine, no, not sine, yeah, for this one sine 0 is 0, right? So this will give you 0. Then y for this one, it is up. For this vector, y is up, right? So we are saying is positive. What when you punch 150 sine 45, it will give you 106.1. So you say 106.1 like that. So that will give us final 106.1 like that. So that's now y component. So now to find the resultant, now we are saying now the resultant, because this question, we want to answer this question. The resultant now will be now root of y component squared plus, let's say x squared plus y squared, just the same. Then you put those values. So we are saying 93.93 plus their squared plus 106.1 by the 106.1 squared like that. So once you root them, you are going to get 141.7 meters as your resultant. So that's your resultant. Okay, so that's how you find the resultant. Okay, so after finding your resultant like this, so let's see how we can find now allow me to lab this. Okay, very simple if you analyze it. So you'll be given multiple vectors. It's important that you analyze it like this. It will be very fast for you. So if we have the resultant like that, how do we find the direction? I said direction, we had x and y, right? We had x and y, of which x it was 93.93 and 93.93. That was our value of y. So we said we used tan theta, you say y over x component like that to find the angle. Master this formula, right? Write it somewhere to find the of multiple vectors or even just two vectors. This is what we'll be using for y and x component like that, right? So what you do is now you are saying now theta is equals to tan inverse open bracket. What is y? Y is what? 106.1 over 93.93 like that. So if you do that, when you punch on a calculator, you're going to get 49 degrees like that. So we are saying the direction, right? So the direction will allow you now to say, was this one negative? Was there anyone? So they were all positive, right? So since they were all positive, you do this. Here is the Cartesian plane, right? Here's the Cartesian plane. Where can we find a positive? Or y and chan, they are positive. It is of this line, right? That's where x and y, they are positive. Y is positive and also x is positive. This side, on all students, something like that, take chemistry, those who remember Sokato. But in this region here, they are all positive. So what you do is, meaning that that vector, it was north of east. So the 45 will be found here, right? So meaning that this is our east, this is our north. So we'll say north of east. So that's the direction. So you see, after finding these things, you measure x and y where they're coming, then you'll be able to see, oh, this is it can be this, it can be this, and you should know how you should do measure, because I said it always start from the x like that. Then even here to start from x and goes there, and this one from x and goes there. So that's how you'll be getting the north of east, the direction, those directions. That's how you'll be finding them. Very simple and easy. So it was a nice situation. It was a nice situation. All right, so you pause the video and delete those things, right? So you can be given multiple vectors and still ask the same thing. So I can give you another scenario, but it will just waste our time. That's how you do it, right? That's how you do it. You analyze it sometimes on a Cartesian plane. Sometimes you can't even analyze it on a Cartesian plane, right? Yeah. So that is it. So those magnitudes, they can be expressed in the form of what's this, force, everything like that. So you'll be told. So let's see now, if we are given to say given the vectors, let's say vector A is 2 I like that, then minus 3 j like that, plus 5 k like that. So they'll be presented like this, ijk. Okay, so that's our A. Then our B, vector B, allow me to write like this, just A, and I put a vector there to show it's a vector, right? So I'll say for B is now, let's say 1, which is just the I, right? Then I say minus 3j, then plus 1k, which is just k, right? So now in this case, I'll ask you to say find a vector plus b vector, right? Then B, I'll say find a vector minus b vector, right? For C, I'll say find a vector dot, which is dot product, b vector, right? So then the D question, I'll say find the angle between, so angle of A and B like that, right? So we start with A. So how do you find A? For this one, is just direct, you add. So we are saying you add respectively, just like you add the matrices. So 2 plus 1 there, that's just 1 for I, because I can't put 1 there. So it's the 3I like that, I solutions. So 3I like that. Then what is negative 3j? They are like terms algebra. Negative 3 minus 3 again. So that is plus negative 3. That will still give you negative 6j like that. Then what is the 1 plus 5? That's 6, right? So that will give you positive 6k like that. You are done. Then for B, A minus B. So when you are subtracting, you subtract also respectively. okay, is subtracted respectively. So what we do is we are saying now this minus that, it will just give us the single data, which is just I. Then this negative 3 minus that, so there is minus, so I'm saying negative 3 minus 3 because there was a minus there before even coming to that, so it's more like negative 3, okay, then minus again minus, which is that negative 3, so that will give us negative 3 plus 3, which is 0, right? So that will give us 0. So we are saying it's now we are subtracting for B, so we are saying this minus that is 1, then that one is plus 0, then you're saying 5 minus 1, that's 4, right, plus 4, okay, like that. So which is just 1 plus 4, okay, so this is just I. So now we find now the dot product, which is A vector dot product B vector, like that. So for these ones, what you do is you multiply to get a number, so you multiply them to get a number. That's what we do. So even before doing that, without doing that, sometimes you can just do what, let me just show you. If you are multiplying k, these are charged, let's say they are charged k times k, this will give you 0. So if you are multiplying j times j, this will give you 0 again, okay, are we there? But if you are multiplying I times j, I dot j, like that, that will give you positive k. That will give you positive j k. But if you are multiplying again j times dot I, like that, this will give you negative k. So if again I say j, that will give us 0. If I multiply I dot I, that will give us 0. Have you seen? So the trick is just here, you master this. The rest, if they are same, then you get a 0. So let's go now. So we have, that's dot product, that's how it cancels those directions, j, I, k. So now we are saying A times B. So we are saying now we are multiplying, so we'll say we'll bring that vector, which is 2I minus 3j plus 5k, then dot open bracket, we are saying now we have 1 minus 3j plus k, like that, right? So that's the vector that we have. So since we have this vector, now we are now multiplying. I said we'll multiply the numbers first. 2 times 1, which is just 2 there, open bracket. For units, it's now it's giving what, I times I said is 0, so you put a 0 there, you are done, you cross like that. Are we good there? Are we good there? No, I forgot one thing. So if it's for I and I, you get a 1. I and I, you get a 1. J and J, you get a 1. If they are all a variable, you do that. So what we do is, allow me just see, I've really made a big mistake. I'm thinking about something else. These ones will be used later in a situation whereby we don't have k and this one. So that's how they will be working when you don't have k. But in this case, since we have k, we have all the 3 things needed, so we won't use this thing, we'll be just going direct. So that is it. So we'll be going now direct. It's now direct because we have everything in order. So what you do is you multiply this time that, okay, but for units you just forget, because this is dot product. A dot product will result in a number, not another vector. So say this times this, that's 1, so you get 2, right? Then plus That's negative 3 times negative 3, that's 9, right? Then 5 times 1, that is 5 still. So when you do that, you are going to have, this is what, 10, 11. So this is 11 plus 5, which is just 16, right? So this is your dot product. So to find now the angle between A and B, we use the same dot product rule. So which state that A dot B, like that, if they are vectors, should give you, it should be equal to their product, their resultant. Let's say resultant of A again is at times the resultant of B, like that, then cos that vector. So this, what you multiply, it is equal to this. So what we do now is we have this here, so we just don't have the resultant of A and B. So let's find the resultant of A and B. So yeah, let's find the resultant of A and B. To find the resultant of A, I'll say A resultant, I'll say the whole vector in the root, because that's vector A. So I'll say 2 squared there, 2 squared, let me just plus, because the square was always result in a positive. So I'll say 3 squared plus 5 squared, like that. So this will give me what? This will give me root 11, like that. Okay, so it will give me root 11 like that. No, 38 if I'm not mistaken. Yeah, it's 38. I don't have a calculator, by the way, so allow me to, so you see 38, like that. So that's our A resultant, like that. Then what about for B? Allow me to write a small b. So a b now will come as everything in the root of b. So that is our b. We have 1 there, 1 squared plus 3 squared plus again 1 squared, like that. So that will give us what? 11. When 9 plus 2, that's 11. So root 11, like that. Okay, so this is root 11. So since this is root 11, what are we going to do? We are going to say, using this rule here, remember we found what? We found 16 as the dot product. So write 16 there is equal to, what is our A? That's how we find we can find the angle between those vectors. So depending the data that you have, there's also cross product. This is dot product. So we are saying for A it's now 38. For B is now 11, then cos theta. We are interested in the angle, right? So we are saying theta, cos theta is equal to this 16 over these two things when you divide. So there's 38, then root 11, like that. So you find that your answer should be something like 50.5 degrees. So that's how you find your angle. Okay, so that's how you find the angles. So that's about dot product. Get it clear. So that's about dot product. Write these somewhere, please. I'm about to lab them, so write them somewhere. You can pause the video and write them somewhere. All right, so that's the angle. That's about dot product. That's how it works when you're given two vectors. Very easy. All right, so let's see another scenario where we involve the cross product thing, and we'll be ready to go. Okay, so let's say given vectors A is equal to, no, let me write it like this. So given vector A, given vector A like that, okay, is given as, let's say 3i like that, plus 5 j. There's no k in this case. You see now how it will be affecting those my I, everything that I will now bring them on board. So we are saying now for vector b, it will be 2i plus 4j, like that. So now I tell you to say find a times b, like that. This is cross product. This one is z. If I say a times b, like that, let me say b. This is dot, a dot, then this is cross, right? So now we're dealing with this one. So to find a, by the way, I'm supposed to write a times b, like that. Okay, solutions. So now to find this one, we are saying now we use this. Now we bring the same vector now on a line, like we can say 3i plus 5j open bracket dot. For b, it's now 2i plus 4j, like that. So now this is now where I bring that issue of how those things are affecting I. That's how I'll drop them. I said if you see, let's say I multiplying times I, like that, right? This will give you 0, right? If again I say j times j, like that, that should give you 0, okay? But if I say I times j, if I say I, so if I is the first term, then just know that you're getting a positive k. So now this is a positive k. But if I say j times I, it's now a negative. Okay, so these are the things to master. Very important. So let's get started now. We'll be multiplying even the units themselves. So 3, this is now, by the way, this is a cross product. So a cross, you cross everything. For a dot, you are just going directly respectively. But for this one, you say it's more like you are multiplying. What's this? Get this one as a column vector, whereby you multiply this time this, I mean as a matrix. 3i, so I'm saying 3 times 2. Okay, I also multiply the units. The units are I and I, so I'll say I times I, like that. They are together, by the way. Then you put a plus. Again, the same 3 times 4. So I say 3 times 4. The units are I and what? Times j, right? Plus again, you say now it's 5. 5j times I. So it's 5 times 2, this 2. Then you say it's now j times I, like that. Then the other thing is 5 plus again you add 5 times 4, right? 5 times 4, then that's j times j, like that. So remember we said I times I is 0, so this is just 6 times 0. Then 4 times that, this will give us positive k, because we said I times j is positive k, I times j is positive k. So say plus, this is 12k, right? Then this time that, that's j times I, which is just negative, so this will give us negative 10. Negative 10 what? J and I is giving you negative k. That's why I've put these negatives for k. Okay, right? Then j and j, that's giving you now 0, because j and j, they are cancelling. That's 0. So we are saying that will give you 12 minus 10, which is just they are all in k's. If you can note that they are all in k, so you say 12 minus that will give you 2k. So that's so in cross product you result in another vector. In dot product you just result in a magnitude, a number to say. So that is it. So after finding this, I can ask you to say find. So this is how you do this thing. So I can ask you to say find now the unit vector which is perpendicular to these vectors. So a unit vector, so if you hear the word unit vector, so a unit vector is just a vector divided by its magnitude. All right, so a unit vector is a vector divided by its magnitude. So what is a unit vector? So a unit vector will be presented by the letter n, like that, like that. Oh, allow me to write like this. So it will be represented by n like that. So this is a unit vector. So a unit vector, it is just a vector divided by its magnitude, right? So a unit vector is a vector divided by its magnitude. Alright, so that's a unit vector. A unit vector, it will be a vector divided by its magnitude. So we are saying a unit vector now will bring that vector. The vector that we had is the vector that where we resulted, we use the cross product will result in a vector. So we are saying the cross product of a and b, because that's a vector, then divide by its magnitude now. So we are saying the same cross product then its magnitude. That's a unit vector. So in this case, our cross product, we found something like 2k like that, over what is the unit of 2k? What's this? The same 2k, we say like that, we square root inside there, right? So it will give us 2k over root 4, right? Because that's a unit vector. What's this? Resultant vector. So then from there, then we are saying this is just 2k over 2, like that. You can divide 2 there, so it will give you 1, which is just k. So that's a unit vector. Perpendicular, that's a unit vector which is perpendicular to that given vector. The same given vector we have used, the perpendicular vector, another vector that is of unit product, I mean a unit vector, should be expressed in this form. So you can find everything like this. Aye? Good. So that is it. Thank you for watching the video. Please, the next thing that we are going to do is the tutorial sheet, but ask for a tutorial sheet using this line. Ask for a tutorial sheet using this line 09700200920. So the name is Alpha Tactic Academy. So you'll find the tutorial sheet. You can just inbox. Thank you very much for watching. The video covers everything that comes in your exam, and the other important stuffs will solve them as we are going through this. Thank you. So we are done this one. Ask another video. Thank you very much.